This is group 5 with math magic. Mathematics over time has always been something important due to education, but have you ever wondered where it came from? My name is Dava Pound, and I will be going over the history of mathematics and a brief history on Pascal's triangle. Okay. Mathematics was founded before the Renaissance era. It was regarded as the science of quantity, whether of magnitudes, numbers, or both. But it wasn't until the 19th century that mathematics broadened and expanded its horizons to symbolic logic, where an increase of drawing conclusions came about. As you can see in the graph, in this diagram, mathematics has definitely expanded over time. I myself would not expect for mathematics to look this complicated, but in simple terms, it actually is not that complicated. Moving on to Pascal's triangle. To give a brief description of Pascal's triangle, Blaise Pascal, a French mathematician who became famous for his namesake, presented a system of showing binomial coefficients, where each number is the sum of the numbers directly above, but when a binomial expression, it's a simple algebraic expression that contains two terms operated by addition, subtraction, multiplication, and positive whole number exponents, such as x plus y to the power of 2. Continuing on the binomial as it expands, it begins to create a symmetrical triangle. Now, to talk more about Pascal's triangle, I will pass it on to my classmate, Bianca.
All right, let me see if I can share this screen. Have you ever sat and wondered, do we really need math? I personally believe so. I think math is fun and very useful for everyday life. For instance, it teaches you life and death information. Like when you're cold, you should go to a corner since it's 90 degrees there. My name is Bianca Porter, and I will be going over Pascal's triangle and how we can use it in everyday life. Why do we use Pascal's triangle? Because of this connection, the entries in Pascal's triangle are called the binomial coefficients. The other main area where Pascal's triangle shows up is in probability, where it can be used to find combinations. To make your own Pascal's triangle, all you need is a pen and a paper and one very simple rule. Each number in the triangle is the sum of two numbers directly above it. Line the numbers up like bricks in a wall. Put ones down the outside of each row and add and like so. Like these two, one is 2, 2 and 1 is 3, and so on. This is an example of a Pascal's triangle. There are many different methods of the Pascal triangle. This one I will show you is called the intertwining petals. You can pick any number inside Pascal's triangle and look at the 6 numbers around it that form alternating petals in the flowers drawn above. If you multiply the numbers in every second petal, you'll end up with the same answer no matter which of the petals you start from. So for example, 1 times 3 times 4 is 12, and 1 times 2 times 6 is also 12. Now, originally, I would be passing it on to Shirlee, our third presenter, but due to some health issues, I will show you how you can use Pascal's triangle in a real-life situation. How can you apply Pascal's triangle to a real-life situation? Say that you want to have 5 children and you want to have your dream family of 3 girls and 2 boys. In the binomial expansion of that corresponds to girl plus boy to the 5th power. So we look at row 5 in Pascal's triangle to find out the probability of having 3 girls and 2 boys. So now I will show you a drawing. of Pascal's triangle. Gotta excuse my drawing. Okay, so basically we look at the fifth row right here. And we use this 1 to the 5th power corresponds to 5 girls, and 1y to the 5th power corresponds to 5 boys. But what your 1 is 3 girls, 2 boys, of course. So it's girl plus boy to the 5th power. Oh God, that's horrible. All right, so you get this equation right here, 1 plus 5 plus 10 plus 10 plus 5 plus 1, which is the 5th row. And you get 10 over 32, which gives you a percentage of 31.25%. So you have a 31.25% of having 3 girls and 2 boys. Now Pascal's triangle works like this. Basically, it's 1 plus 1 gives you 2, 2 plus 1 gives you 3, 3 plus 1 gives you 4, 3 plus 3 gives you 6, 4 plus 6 gives you 10, and so on and so on. And that's how you can use Pascal's triangle in a real life situation.
Well, concluding with this, learning in mathematics and Pascal's triangle, they both go hand in hand with one another. And I would like to say that is it for group 5. Thank you.
Thank you.
Bye.